Theory of Democritus, thought about in 460 BC by Democritus. Democritus sought to divide matter into smaller pieces and observe the properties of the divided pieces. Democritus thought if a stone was divided in half, the two halves would have the same properties as a whole. If you keep cutting it into smaller and smaller pieces, then at some point it would not be observable by human eyes. This idea was never been thought of before this point. He named the small pieces of matter atoms, which means invisible in Greek. Atom is invisible particles in void or empty space, and all matters are made of atoms. Atom is the particle that determine the properties of matter. That's Democritus. This is Democritus' model. Dalton's atomic theory, proposed during 1803 by John Dalton. Dalton studied different kinds of gas observation in water and observed that water does not absorb every kind of gas alike. They observed different gas absorption in water under the same pressure, but water does not absorb every kind of gas alike. He concluded that different gas atoms have different masses. Atomic elements combined, in this case gas and water, in fixed ratios naturally differ due to their unique atomic weight, that which answers the question why they react different. It's a first proof scientific theory of the atom because no one has previously identified atoms through science experiments. The bullet point is, all matter was composed of atom, invisible, and it cannot be altered or destroyed by any chemical reaction. For Dalton, this all stands, but atoms cannot be altered or destroyed by chemical reactions. All matters are combined in defined ratios. Atoms are identical in its element and different in size and mass in all the elements. That's Dalton's. And this was Dalton's example. Plum pudding model proposed in 1897 by J.J. Thomson. J.J. Thomson demonstrated that cathode rays were negatively charged using a cathode ray tube. Realizing that the accepted model of an atom lacks the count of negatively or positively charged, he proposed a model of the atom that looks like a plum pudding with negative charges, which he calls electrons, in the positively charged matter. Thomson's model of the atom explains some of the electrical properties of the atom. For J.J. Thomson, all of those still stands, and he said the atom contains negative charged electrons, and atom's electron contains mass. And this is Thomson's plum pudding model. Rutherford model proposed in 1911 by Ernest Rutherford. Rutherford and his team bombarded a gold foil with alpha particle and observed there's particles that reflected at a large angle. Most of the alpha particles passed unaffected through the gold foil as expected, but some of the particles were deflected at an angle, some straight back. This was contradicting the plum pudding model of the time. Rutherford concluded that there are lots of space in an atom, and the positively charged is small and dense in the center of the atom with like negatively charged electrons surrounding it. He calls this the nucleus. For Rutherford, all of this still stands, and he says that atom contains negatively charged electrons surrounding the nucleus. This is something he added new. And then he said major space in an electron is empty, only a small dense positively charged nucleus in the center. And then this is an example of his model. Bohr model, or Rutherford-Bohr model, developed in 1913 by Niels Bohr. Using Planck's constant, Bohr found that atom's energy doesn't follow the classical mechanics. In Rutherford's model, the atom was unstable according to classical mechanical and electromagnetic theory. They thought that electrons would lose their energy during the orbit and crash into the atom. However, the atom seemed to be stable. Bohr modified Rutherford's model by giving electrons fixed size and energy orbit. He proposed that energy of an electron depends on its size of the orbit. And for Bohr, all of this also still stands. And he said that atom containing negatively charged electrons surrounding the nucleus in a stationary and stable orbit. And then he said that energy is absorbed when an electron rises an orbit higher and loses energy when it drops its orbit to a lower one. And he said each orbit has a specific energy associated with it. And this is his model. This is all the bullet points with a clear view.